So first, let us look at the operations of addition and subtraction. As we have seen before, to discuss the operations of addition and subtraction, we'll take the algebraic representation of complex numbers. So let us take two complex numbers, x1 plus iy1, which is z1, and x2 plus iy2, which is equal to z2. Now, how do we add these two complex numbers? We have already seen this. So z1 plus z2 is nothing but we add the real components x1 plus x2 and we add the imaginary parts separately, I times y1 plus y2. So for the complex number z1 plus z2, the real component is x1 plus x2. That is, the x component is x1 plus x2 and the y component is y1 plus y2. So did you come across this sort of addition somewhere else? So as you can remember, this type of addition also happens in the topic of vectors. For example, if you have two vectors in the xy plane, so if one vector a bar is some x1 times I cap plus y1 times j cap, this vector is represented by the point x1 y1 on the xy plane. And if you have a vector b bar which is x2 I cap plus y2 j cap, this vector will be represented by the ray joining the origin and the point x2 y2. So how do you add these two vectors? A bar plus b bar is nothing but x1 plus x2 times I cap plus y1 plus y2 times j cap. So we add the I component separately, we add the j component separately. Now what are the coordinates of the final vector? Again, x1 plus x2 in the x direction, y1 plus y2 in the y direction. So does these two additions look exactly same? Yes. So in terms of addition and subtraction, complex numbers can be thought of as vectors. This is a very important simplification. And once the complex numbers can be thought of as vectors, the laws of vector addition can be used for complex numbers also. So now if you have a number z1, a complex number z1, it can be thought of as a vector OZ1. And if you have a complex number z2, this can be thought of as a vector z2. So z1 represents a vector joining the origin with the point z1. z2 represents a vector joining origin with the point z2. So now what is z1 plus z2? So z1 plus z2 can be given by the endpoint of diameter after completing the parallelogram. So with z1 and z2, we complete a parallelogram. Now BC, let BC be parallel to OA and AC be parallel to OB. They meet at a point C. Now OC bar, the vector OC bar represents the sum of OA bar and OB bar. So this point represents the complex number z1 plus z2. So z1 plus z2 is the complex number which is the endpoint of the diameter starting from origin of the parallelogram whose coterminous sides are z1 and z2. Now, how do you subtract two vectors? If you want z1 minus z2, so how do we do this? So we take plus z1 and add minus z2 to z1. So z1 is here. So z2 is OB bar. What is minus z2? Minus z2 is just the vector in the opposite direction. Same magnitude in the opposite direction. So this is, let this point be D. So this point is minus z2. So this is z1, this is minus z2. So how do you add z1 and minus z2? Again we complete the parallelogram, right? So we can complete the parallelogram, right? So you can complete the parallelogram. Now they are intersecting at this point. So this diagonal represents, this point represents z1 minus Z2. So this point represents Z1 minus Z2, and this point represents Z1 plus Z2. So out of these two, Z1 minus Z2 is more important to understand. So let us look at some properties of Z1 minus Z2. So what is the direction of Z1 minus Z2? So what is the direction of Z1 minus Z2? So as you can very clearly see, O, B, A, E also forms a parallelogram. O, B, A, E also forms a parallelogram. Now, OE is exactly same as BA. So OA bar is exactly same as BA bar. So the direction of OE bar is exactly same as the direction of BA bar. So what is the direction of Z1 minus Z2? This direction is exactly same as the direction of the ray joining Z2 to Z1. So the direction of the complex number Z1 minus Z2 is same as the ray joining Z2 to Z1. Z2 to Z1. So the direction of Z1 minus Z2 vector will be in the direction of the ray joining Z2 to Z1. Is it clear? OE bar has the same direction as BA bar, that is the ray joining Z2 to Z1. And what is the magnitude of Z1 minus Z2? What is the magnitude of Z1 minus Z2? This is exactly same as, this length is exactly same as this length. So the magnitude of Z1 minus Z2 is equal to the distance between Z1 and Z2. So these are the two important things which you need to understand. Z1 minus Z2 has the direction along the ray joining Z2 to Z1, and Z1 minus Z2 has a magnitude equal to the distance between the points Z1 and Z2. So let us see how you can use this concept to your advantage. So in the concept of subtraction, you need to remember two important things. The first thing is, whenever you look at an expression like this, mod of Z1 minus Z2. So what is the meaning of this? This is the magnitude of the vector Z1 minus Z2. So we have seen that the vector Z1 minus Z2 has the magnitude equal to the distance between Z1 and Z2. So magnitude of Z1 minus Z2 is nothing but the length of OE, and the length of OE is exactly same as the length of BA. Hence whenever you have Z1 minus Z2, you have to start reading this expression as the distance between the complex numbers Z1 and Z2. For example, if you have Z minus 4, so how do you read it in English? So mod Z minus 4 is one way. The other way in which you can read this is the distance between Z and the complex number 4. 4 is a purely real number, so it lies on the positive real axis. So the distance between Z and 4 is represented by mod of Z minus 4. So whenever I see this, I read this as distance between Z and 4. So 4, as you should understand, is a complex number, 4 plus 0i. Z is any complex number. So if I say mod of Z minus 4 is equal to 3, what is the meaning of this? The distance of the complex number Z from the complex number 4 is equal to 3. So what are the complex numbers which satisfy this equation? If I ask you to solve this equation, so what is the general idea that you get from reading this equation? The distance between Z and the complex number 4 has to be equal to 3. That means if you draw the organ plane, 4 lies somewhere here. Now the distance between my complex number z and 4 has to be equal to 3. That means obviously this z lies on a circle with center as 4 and radius is equal to 3, right? So my z will lie on a circle with 4 as center and radius is equal to 3. So I hope you have understood the concept of mod of z1 minus z2. So mod of z1 minus z2 is the distance between the complex numbers z1 and z2. Next, so what is the argument of z1 minus z2? Whenever you get argument of some complex number minus some complex number, how do you understand it? What is the argument of z1 minus z2? So OE is a complex number z1 minus z2. So this angle is nothing but argument of z1 minus z2. So this will be exactly equal to the angle made by the ray z2 z1. So argument of z1 minus z2 is exactly equal to the angle made by a ray joining z2 to z1. Direction is important. z2 to z1, final to initial. Angle made by the ray joining z2 to z1 with the positive direction of real axis. That is, if you want the argument of z1 minus z2, you don't need to go here. You can directly get the argument of z1 minus z2 from this diagram. So join the ray z2 to z1, the angle that this ray makes with the positive direction of x-axis, the positive direction of real axis. This angle is nothing but the argument of z1 minus z2. So as you can see, this angle will exactly be equal to this angle. Let us take an example. If you have argument of z minus 4 is equal to pi by 6. Argument of z minus 4 is equal to pi by 6. So what are the complex numbers z which satisfy this equation? So what is the meaning of this? If you take the organ plane, you know where 4 is. 4 is a purely real number. It lies on the real axis. Now, argument of z minus 4 is equal to pi by 6. How do you analyze this? That means the angle made by the ray joining 4 to the complex number has to be equal to pi by 6. So if I join 4 with my complex number, the angle that it should make with positive x-axis has to be pi by 6. So obviously, if you draw a ray at an angle of pi by 6 with the real axis, any point on this ray satisfies this equation, right? Because if you take any complex number z here, the ray joining 4 to z is making an angle of pi by 6 with x-axis. So what is the solution of this equation? The solution of this equation is a ray starting from 4 at an angle of pi by 6 with the real axis. So I hope you have understood the meaning of addition and subtraction. So you have not concentrated much on addition because subtraction is the most commonly used operation in solving problems. So in terms of subtraction, you need to remember two things. What is the meaning of mod of z1 minus z2? Is nothing but the distance between z1 and z2. What is the meaning of argument of z1 minus z2? It is the angle made by the ray joining z2 to z1 with the positive direction of real axis.